Guys, welcome back to my vlog. So, last week, I asked you guys in my Twitter what I can do for my next vlog. So, there's a boy who asked me if I know something about chemistry and if I can help him in his assignment about stoichiometry. And guess what? Chemistry is my favorite subject. So, to that boy, I got you. Kidding aside, I invited some of my classmates to share about stoichiometry. So, come and join us for today's tutorial video. Let's go! Here. Hi guys!
Hi!
Guys, are you ready?
No!
Oh my god! So now guys, I'm with my classmates and we will talk about
Stoichiometry!
Let's start!
Did you know? Substances take up space and have mass. It is made up of molecules which are often need to be measured. It is so tiny that we are not able to see it with the naked eye. So, scientists discovered a way for us to measure it, and it is the mole concept. Mole concept is used to measure the amount of a substance which is created by a group of atoms. Atoms, which is the basic unit of a chemical element, also has mass. That's why we have this thing called atomic mass. Atomic mass is the mass of an atom and sometimes called atomic weight. It is found in the uppermost right of an element in the periodic table.
Molar and molecular mass. Mole is a unit of measure that helps us compare particles of any given substance, and its mass have number of molecules, which is the Avogadro's number. It is a constant used to signify the number of molecules in one mole. Avogadro's number is equivalent to 6.022 times 10 raised to 23. To get the number of moles, you either be given a mass or the number of particles. Avogadro's number is the number of atoms or molecules in one mole of a substance. The formula in getting the molar mass and molecular mass is the same. Get the molar mass of the compound by adding the total atomic mass of elements that is within the compound. The unit of molar mass is grams per mole, and for molecular mass is AMU. 1 mole of carbon dioxide. In carbon dioxide, we have 1 carbon and 2 oxygen. We have to get the atomic weight of carbon and oxygen. So, the atomic weight of carbon is 12.01 and the atomic weight of oxygen is 16. So, 1 carbon, which is 12.01, and 2 oxygen, which is 16 times 2. Then, add the product and the atomic weight of carbon, which is 44.01 grams per mole or AMU.
Hi guys, today I'll be discussing molecular formula and empirical formula. So what is molecular formula? Molecular formula is how many atoms of each element are in a compound, while empirical formula is the simplest or most reduced form ratio of atoms in a compound. So for example, C4H8 will then turn into CH2 because CH2 is the simplest form of C4H8. So I've made the problem regarding this matter. So, a compound has analyzed and found to contain 13.5 grams of calcium and 10.8 grams oxygen and also 0.675 grams hydrogen. So, what is the empirical formula of the compound? So, first thing we'll do is to find its mole. So you'll simply divide it by its molar mass. So if we solve this, we'll get So we have to divide this all by the smallest number we get. So the empirical formula would be or we can say so that's all. So let's see what Mr. Tindoc can say.
So hello guys, so my topic is percent composition by mass. So it is the percentage composition of an element in a compound. So here's the formula. N times total molar mass of an element all over total molar mass of the compound times 100 to get the percentage. Here are some problems. Mass percentage of hydrogen in H2O. So solution. First we will find that each molar mass of the atom and to get the total molar mass of the compound. So hydrogen, there are 2 atoms of hydrogen and times the total molar mass of hydrogen, 2 times 1.008 and add it to the molar mass of oxygen, we will get 18.016 and use the first formula, substitute it and we will get 11%. So that's all for now guys, thank you.
That's all for today. I hope you learned something from us, and if you have some questions, just write it down below. Bye guys! Don't forget